Welcome to my class. Introduction. Class Standard 12. Subject Higher Mathematics. First paper. Chapter name Permutations and Combinations. Exercise 5B. Lecture 4. Today's lesson. Explain the combinations. Explain the complementary combination. Prove and apply the different formulae for determination of combination. Combination. Each of the groups or collections that can be made out of a given number of things, taking some or all of them, is called a combination. For example, the different groups. Here, groups is an important word or collection of three different letters A, B, C taken two at a time are AB or BA as group or team. So in a group the member AB or in a group the member BA both are same. That's mean here omitting order. That's mean AB and BA are same. Similarly, BC or CB same. CA or AC same. That's mean total group here 1, 2, 3 or total collection 1, 2, 3 or total combinations 1, 2, 3. Therefore, the number of groups or collections or combinations is 3, which can be written as 3C2. That's mean total number of letters 3 taken 2 at a time. We can write 3C2 or 3C2 like this way, or C32 or 32. You can take any one. Normally we'll use like this form. Okay. Therefore 3C2 this equal to 3. Clear? Again, the different groups or collections of three different letters A, B, C taken 3 at a time are ABC or ACB or BAC or BCA or CAB or CBA. All are same, not different, because this is a groups or team. So the member of this group ABC and ACB or BAC or BCA or CAB or CBA are not different, same. So here will be only one group. Okay, therefore the number of groups or collections or combinations is 1, which can be written as 3C2. Sorry, 3C3. Therefore 3C3 is equal to 1. Clear everyone? Number of combinations. To find the value of NCR, or to find the number of combinations of n different things taken R at a time, where n r belongs to natural number and n greater than or equal r. Okay. Solution: let the required number of combinations be NCR. That's mean we have to find the value of NCR. So at first let this every combination consists of r different things. Okay, I have mentioned different. Now, are different things in every combination can be arranged among themselves in R factorial ways. Such type of NCR combinations can be arranged in NCR into R factorial ways. And this is equal to the number of permutation of n different things taken R at a time. That's mean NCR this into R factorial and this part equal to NPR. Therefore NCR and this equal to, we can write n factorial divided by n minus R factorial. We know this relation. So therefore NCR this equal to n factorial divided by R factorial. That's mean this will be here divide R factorial into n minus R factorial. This is a value of NCR and this is a most important formula. You have to always remember NCR is equal to n factorial divided by R factorial into n minus R factorial. Clear? Complementary combination. To prove that the number of combinations of n different things taken R at a time is equal to the number of combinations of n different things taken n minus R at a time, that is NCR. It's mean from n different things taken R at a time. This is a number of combinations, and n different things taken n minus R. This is another number of combinations, but this and this are equal. Proof by the definition of combination we get n c n minus r this equal to n factorial divided by r factorial. R mean n minus r factorial into n minus r. N minus mean n minus n minus r factorial. Okay, now calculate n factorial, here n minus r factorial, here n minus n plus r minus n plus n cut will be n factorial divided by n minus r factorial into r factorial. This equal to, you can write n factorial divided by r factorial into n minus r factorial. Just I have written here in arrange. At first I have written r factorial, then n minus r factorial. So n factorial divided by r factorial into n minus r factorial, this equal to, we can write NCR. That's mean this and this are equal. Therefore NCn minus r this equal to NCR, or NCR is equal to NCn minus r. Clear? Prove that NCR plus NCR minus 1 this equal to n plus 1 CR. Proof left hand side is given this, and this equal to, you can write NCR mean n factorial divided by r factorial into n minus r factorial plus NCR minus 1 mean n factorial divided by r minus 1 factorial into n minus r minus 1 factorial. Now calculate, here same, here will be n minus r and here n minus r plus 1 factorial. Just calculation. This equal to n factorial divided by, we can write r factorial this equal to r into r minus 1 factorial, because here is given n minus r 1, sorry, r minus 1. So we have to convert r factorial this equal to r into r minus 1 factorial. And as here is given n minus r plus 1 factorial, but here is given n minus r factorial, so n minus r plus 1 this equal to, we can write n minus r plus 1 into n minus r factorial. That means we have to match this with this. That means this and this are same. As a result, we can take common n factorial divided by r minus 1 factorial into n minus r factorial. Okay, and after taking common, here will be 1 by r plus here will be 1 divided by n minus r plus 1. Okay. S n factorial is equal to n minus n into n minus 1 factorial. This line will be here for clear concept. Okay, not along this line. This line will be here. Just calculation here. LCM will be r into n minus r plus 1. The result here will be n minus r plus 1 plus r cut, and the result n factorial divided by r minus 1 factorial into n minus r factorial. Here will be n plus 1 divided by r into n minus r plus 1. This equal to, we can write n plus 1 into n factorial, and here r into r minus 1 factorial into n minus r plus 1 into n minus r factorial. And this equal to, we can write n plus 1 factorial as n into n minus 1 factorial mean n factorial, and here will be r factorial, and here will be n minus r plus 1 factorial. This equal to, we can write here same, but here also same, but this equal to, we can write n plus 1 minus r factorial. So this equal to, we can write n factorial divided by r factorial into n minus r factorial. This equal to, we can write NCR, but here is given n plus 1 factorial divided by r factorial into n plus 1 minus r factorial mean n plus 1 CR. This is the right hand side. Proof is complete. Clear? Conditional combination. The number of combinations of n different things taken are at a time in which p less than or equal to r. Particular things always occur. If p particular things always occur, the number of combinations of the rest n minus p things taken r minus p at a time is n minus p cr minus p. The number of combinations of n different things taken are at a time in which p particular things never occur. If p particular things never occur, the number of combinations of the rest n minus p things taken are at a time n minus p cr. The number of combinations of n different things taken at least one at a time is 2 to the power n minus 1. Proof. The required number of combinations is equal to the sum of the combinations of n different things taken 1, 2, 3 n at a time. As you have to take at least one, that's mean minimum you have to take one. You can take 2, you can take 3, you can take 4, or you can take 5, or you can take n. Okay, that's mean as here is from n different things. So from n different things, when you will take one, the number of combination will be NC1. When you will take 2, number of combination will be NC2, and when you will take 3, number of combination will be NC3. When you will take n, the number of combination will be NCN. Clear? Adding 1 here, 1 plus NC1 into 1 plus NC2 into 1 square plus NC3 into 1 cube plus plus 1 to the power n, because n this equal to 1 minus 1, as we have add here 1, so we have to subtract minus 1 from this. Okay, but by binomial theorem we know 1 plus NC1 into 1 plus NC2 into 1 square plus NC3 into 1 cube plus 1 cube, this equal to 1 plus 1 to the power n minus 1, that is this equal to 2 to the power n minus 1. This is the required number of combination. Clear? For example, a man has 6 friends. How many ways he can invite one or more of them to a dinner? One or more. That's mean he have taken at least one. At least one mean he can invite one friend, or more mean, or he can invite 2 friend, or he can invite 3 friend, or he can invite 4 or 5 or 6, or 6 mean all. Okay, therefore the number of combinations for the invitation of 6 friends, this equal to 6c1 plus 6c2 plus 6c3 plus 6c4 plus 6c5 plus 6c6. By applying formula, we can write 6 factorial divided by 1 factorial into 6 minus 1 factorial. Similarly, others part will be same. 6 factorial, this equal to, you can write 6 into 5 factorial, because after calculating of denominator, here will be 1 factorial into 5 factorial. As a result, 6 factorial equal to, we can write 6 into 5 factorial. Here will be 4 factorial, so 6 factorial equal to, we can write 6 into 5 into 4 factorial. And here will be 3, so here 6 into 5 into 3, not 4. It will, oh yes, 4, no problem. 6, 5, 4. Here 3 factorial into 3 factorial, and others will be like this, so you can write. Now 5 factorial cut, here will be 6. Here I have written here also 3 factorial. That's mean 6 into 5 into 4 into 3 factorial. As a result, 3 factorial cut will get 5 into 4 mean 20 and 6, and 3 factorial, this equal to 6. 3 factorial mean 3 into 2 into 1, that is equal to 6. Okay, here will be again follow 6 into 5 into 4 into 3 factorial. Again follow this, here will be 6 into 5 into 4 into 3 factorial, and 3 factorial cut 6 into 5 into 4 means 20, and 3 factorial, this equal to 6. Okay, you have to give the correction. And like this, here 30 by 20, here 6 by 1, here 1 by 1. This equal to 6 plus 15 plus 20 plus 15 plus 6 plus 1. This equal to 63 OS. That is 2 to the power 6 minus 1 OS. 2 to the power 6 means 64 minus 1 means 63 OS. This is the required answer. The number of combinations taken any number at least at a time when P things are like of one kind, Q things are like of another kind, and R things are like of third kind, and K things are different, is P plus 1 into Q plus 1 into R plus 1 to the power into 2 to the power K minus 1. But if there is no unlike things, then K equal to 0. Thus the number of combinations, this equal to P plus 1 into Q plus 1 into R plus 1 minus 1. That's mean 2 to the power 0. 2 to the power 0 mean 1. Okay, that's mean we have right here this part. Okay, minus 1. Example, a man has 10 taka notes, 5 taka notes, 2 taka notes, 1 taka note. In how many ways can he donate to a charitable fund? Solution: the man can donate in 10 plus 1 into 5 plus 1 into 2 plus 1 into 1 plus 1 minus 1. This is equal to 395 OS. How 10 plus 1 or 5 plus 1? For clear concept, here follow. For 5 taka notes, I have taken 5 taka notes. I can take also 10 taka note, no problem, or 2 taka note. Just for clear concept, I explain. For 5 taka notes, he can donate the number of 0. Number of 0 mean he cannot donate any 5 taka note, or 1 5 taka note, or he can donate 2 5 taka note, that's 10 taka, or he can donate 3 5 taka note, that's mean 15 taka, or he can donate 4 5 taka notes, that's mean 20 taka, or he can donate 5 5 taka notes, that's mean 20 taka. So OS will be 5 plus 1, that means 6 OS, that means 0 plus 1 plus 2 plus 3 plus 4 plus 5. That is a way. That's mean 0 mean this is a one way. 1 mean another way. 2 mean another way. 3 mean another way. That means total 5 plus 1 equal to 6 ways. Clear? Similarly for 10 taka note, we can donate in 10 plus 1 ways, or for others note we can donate 2 plus 1 and 1 plus 1 ways. Clear? Some more important formulae. The number of combinations taken at least one of each kind in which P things are alike of one kind, Q things are alike of another kind, and R things are alike of third kind. This is equal to 2 to the power P minus 1, 2 to the power Q minus 1 into 2 to the power R minus 1. 6 number P plus Q things will be distributed into two groups A and B, in which one group contains P things and another group contains Q things in 2 factorial divided by P plus Q factorial divided by P factorial into Q factorial OS. 7 number P plus Q things will be distributed into two groups, in which one group contains P things and another group contains Q things in P plus Q factorial divided by P factorial into Q factorial OS. 8 number, if two Q things will be distributed equally in two groups A and B, then the number of combinations will be 2Q factorial divided by Q factorial whole square OS. Two Q things will be distributed into two groups, in which each group contains Q things in 2Q factorial divided by 2 factorial into Q factorial whole square OS. Relation between permutation and combination is NPR equal to NCR into NRPR equal to NCR into R factorial. For example, the number of permutations of 6 different things taken 4 at a time is 6p4. This equal to the number of combinations of 6 different things taken 4 at a time, 6c4, into the number of permutations taken 4 at a time, 4p4, that is equal to 4 factorial. That's mean 6p4, that's equal to 6c4 into 4p4, that's means 6c4 into 4 factorials. Clear? Now homework. Solve the problem related to the lecture and submit the copy in the group. Date of submission 28/2020, time 9 p.m. So today up to this. Thank you to all everybody.